Alright, hi everyone. This is Solving Systems Day 2. This will have a lot more focus on word problems and then a little bit more different systems of equations that we will cover, which will be on the back. Okay, the warm-up is just review, so this would be a good place for you guys to pause and try it on your own and then come back and check your answer. Okay, so assuming you're checking your answer right now, if we want to determine if this is a solution to this system, we want to know if this coordinate satisfies both equations. Okay, here's my x and here's my y. So if I substitute into the first equation, I would have 1/2 equals 1 over 2. 2 minus 1 is 1. So I would have this, which 1/2 does equal 1/2. So that's good. It satisfies this equation. If I substitute into the other equation, I would have 1/2 equals negative 1/8. Let's see, 2 minus 3, that gives me negative 1, and 2 plus 2 is 4. Okay, I would do this part first. So that means that I have 1/2 equals negative 1/8 times negative 4. The negatives, negative times negative is going to end up making a positive. And if an eighth of 4 is 1/2, you could also say this and say 1/8 times 4 is 4/8, which is the 1/2. So then that's true, it does satisfy. So is it a solution to the system? You don't really need to give me too much more. If you've given your work here to justify, a yes is sufficient. Okay, solving the system over here, notice that this one is solved for y, so I can take this y value and I can substitute it into here. So I'm going to rewrite that equation, substituting in for y. So I'm going to say 4x minus 4, and I'm going to put parentheses, since I'm multiplying, 2 plus the square root of x minus 4, and then that equals 16. So notice this is the same equation as this one, it just has a different y value. Okay, so there's a couple ways that you can go about this. I am going to distribute here. So I'm going to distribute this here. Just make sure you pull that negative. You could say then 4x minus 8 minus 4 times the radical of x minus 4 equals 16. Okay, at this point we should be noticing, if we haven't already, that there's one radical. We're going to have to get it by itself so that we can square it. So in order to get it by itself, I need to move these two terms. So I'm going to be left with a negative 4 times the square root of x minus 4 equals, I need to subtract this 4x, and I also need to add this 8. So if I subtract the 4x, now it's negative. If I add 8 to this side, that becomes plus 24. Okay, here I want to divide by negative 4. And I divide by negative 4 over here. So I get x minus 4 square root of that equals, I need to divide both of these by 4, so I actually need to divide this by negative 4 as well as this by negative 4. Okay, so negative 4 divided by negative 4 leaves me with just a positive 1x. 24 divided by negative 4 leaves me with a minus 6. I need to square this, so I square this. If I'm squaring this, that means I'm expanding it, so that means I'm saying x minus 6 times x minus 6. Don't distribute, you cannot because of that minus sign. Okay, so I'll be left with x minus 4 equals x squared minus 12x plus 36. I can see that it's quadratic, so I want to set it equal to 0. When I subtract this x over, that'll give me a negative 13x. And when I add 4, that's going to give me a 40. Okay. When I go to factor, let's see. I need a minus and a minus. Factors of 40 that sum to give me 13 would be a 5 and an 8. So I have x equals 5 and 8. Okay, remember, not only do I need to check for extraneous solutions, but this is also a system, so I need a coordinate. Okay, so I'm going to start by saying 5 comma blank. That way I know it's a coordinate. 8 comma blank. Okay, I'm going to substitute back into the radical, since that's where I really am going to see if there's an extraneous solution. So if I check my 5, let's see. So that will give us y equals 2 plus, I'm going to substitute that 5 in. 5 minus 4 is 1. So square root of 1 is 1 plus 2. That means that this gave me a y value of 3. Okay, so I want to check now to see if that coordinate satisfies the other one. And again, it's that radical is what I'm worried about. So if I check 5, 3 and substitute it into here, I would have 4 times 5 minus 4 times 3. And I want to know if that equals 16. So this is 20 minus 12, which is 8, which is not 16. So this is actually an extraneous solution. Okay, again, this gave me 20 minus 12, which is 8, which is not 16. So that's an extraneous. All right, I need to check the 8. So I would say y equals 2 plus the square root. 8 minus 4 is 4. So square root of 4 is 2, plus 2 is 4. So I want to check and see if 8, 4 works in the other equation. Okay, so I'm going to say 4 times 8 minus 4 times my y. And I want to know if that equals 16. So this gives me 32 minus 16, which is 16. So then this solution does work. Okay. All right. So let's move on to some word problems. Okay, so this problem, we're going to notice in setting it up that it's not really a system, but we're going to use it to help us in number 2 where we do create a system. Okay, it says a right triangle has a hypotenuse of 25. So I'm going to start by drawing a right triangle. And the hypotenuse is 25. The length of one leg is 3 more than 3 times the other. I have no idea what that other is, so I'm going to call it x. And now if I know that that's x, I go back to 3 more than 3 times the other. That would mean that this has to be 3x plus 3. So now I know all 3 sides, at least an expression for them. It says, what is the perimeter? Well, in order to find the perimeter, I have to add up all 3 sides. But in order to have all 3 sides, I need x. Okay, so then that's what should lead me to thinking if I need x, I need an equation. Well, I can't add these up and set it equal to anything because I don't know what the perimeter is. But if you think right triangle, you hopefully are remembering Pythagorean Theorem, which is a squared plus b squared equals c squared. And I have an a, b, and a c, so I can substitute in here. So I can say these are interchangeable, a and b. So I'm going to say x squared plus. If I'm squaring something, it means I'm multiplying it by itself. So I'm just going to write that out and say 3x plus 3 and expand it and say 3x plus 3 equals 25 squared. Okay, so if I multiply this out, I'm going to get x squared plus 9x squared plus 9x plus 9x plus 9, lots of 9s, equals 25 squared is 625, which for this one we're going to use a calculator. So if you don't have a calculator out already, go ahead and get it out. Okay, if I combine like terms, this is going to give me a 10x squared. 9 and 9 makes an 18x. And if I subtract, I can see I'm going to have to set equal to 0. So if I subtract 625, I'm going to get 616 equals 0. So unfortunately, factoring is not really going to be an option with such a large c value. I can divide all of this by 2, though, and make the numbers a little bit smaller, and make it a 5x squared plus a 9x, and then minus 308. Okay. Completing the square is not a good option for this because I'd have to get rid of that 5, which makes this a fraction. So unfortunately, we're going to have to use the quadratic formula. So I'm going to go over use quadratic formula. So quadratic formula says x equals the opposite of b. So this is my a, this is my b, and this is my c. Okay, so opposite of b would be negative 9 plus or minus b squared. So that's 81. Minus 4 times my a and times my c. Okay, square root of all of this. And then remember, everything is over 2 times my a value, which is 5. Okay, when we use quadratic formula, we really just want to simplify the radical. So I have negative 9 plus or minus, and I'm going to use my calculator here. I notice I'm not going to put the square root in. I'm just going to say 81 minus 4 times 5 times negative 308. So it gives me 6241. So 6241, and then that's all over 10. Okay, from here I'm going to get two solutions. And watch how I put it in my calculator. I'm going to say negative 9 plus the square root of 6241. I'm going to hit enter, and then I'm going to divide that by 10, which is 7. Okay, and I'm going to do that again, and I'm going to say negative 9 minus the square root of 6241. And then I'm going to divide that by 10, which gives me negative 8.8. Okay, if I look back at my triangle for my sides, negative 8.8 does not make sense. It would make this one right here a negative length, but 7 does make sense. Okay, so if I know that x is 7, I can come back here and say, well, that leg now is 7. And 7 times 3 is 21, plus 3 makes this side 24. And now that I know all three sides, I can say the perimeter is 7 plus 24 plus 25. So my perimeter is, let's see, this gives me 31. 31 and 25 makes 56. And this is measured in centimeters. And that would be my perimeter. Okay, so like I said, really not a system, but we're going to use that to help us set up this next one. So this one's pretty similar. It says a right triangle has a hypotenuse of 25. So again, I'm going to start by drawing a right triangle with a hypotenuse of 25. And the sum of the legs is 35. What is the area of the triangle? Well, in order to find the area of the triangle, I would need to know what this length and this length is, because area of a triangle is equal to 1/2 base times height, and the base and the height must be perpendicular. So, I could be thinking right now that it's maybe this problem up here, since they both have a hypotenuse of 25, but notice if you add 24 and 7, you do not get 35. So, we're going to get different legs. So, let's look at what we do know. We know that the sum of the legs is 35, but we don't know what those legs are. So I could call one leg x and I could call one leg y, which means then I could say the sum of their legs is 35. And now I have an equation. But I can't solve that equation. I also know, though, that Pythagorean Theorem says this leg plus this leg, or sorry, this leg squared plus this leg squared equals the hypotenuse squared. And now I've set up a system because I have two equations with the same variables. Okay, and now we're going to go through and solve this. So, first thing, I would solve for one of these variables. Okay, so I'm going to say here, I'm going to subtract, it doesn't matter which one you subtract, I'm going to subtract the x. I'm going to say y equals negative x plus 35. So if I know that this is my y value, if I know that this is my y value, I can come substitute into here. So when I rewrite this equation, it's going to be x squared plus, and remember if I'm squaring it, I'm just going to expand it, negative x plus 35 times negative x plus 35 equals 625. Okay, if I simplify, I'm going to get negative x times negative x is x squared minus 35x minus 35x, and I don't know what 35 squared is, so 35 squared is 1225. Okay, so plus 1225 minus, or equals, sorry, 625. Okay, simplify further. I'm going to get a 2x squared. Let's see, this gives me minus 70x. I'm going to pull this 625 over, so minus 625. I get 600. So plus 600 equals 0. Okay, I'm going to factor a 2 out, making the numbers a little bit smaller. Alright, so at this point the numbers are pretty big, at least in terms of that c value. So you could use Pythagorean Theorem if you wanted. Like I said, on the test I'm not going to give you outrageous numbers, they're going to be reasonable. And to be honest, everything's going to factor. it's a quicker method, and it's not where I want to waste your time. So this is factorable. So if you're trying to figure out ways that it could factor, let's see. We know that this has to be a minus, and this has to be a minus. So I'm looking for factors of 300 where the sum is 35. So let's see. I could do 30 times 10. Okay, but the problem is 30 plus 10 is 40. So I need the numbers to be a little bit lower. Okay, so I could try, let's see, 20. So 20 times 15 is actually where it's at. So 20 times 15 gives me the 300, and then adding them gives me the negative 35. So that means I'm going to end up with x equals a 20 and a 15. Okay, again, the numbers here are pretty big. On a test, they would not be. And if it takes a little bit longer in your homework, you know, it's the idea of factoring, okay? So let's see, we have 20 and 15. So if we substitute a 20 and a 15 in, so here's the thing. If this is a 20, then this would have to be, so, all right, so let's go this way. If this is a 20, go back to here. So if this is a 20 right here, 20 plus what is 35? Then that would be a 15. So that would have to be a 15. Or think about it this way. If I said that x was 15 here, then 15 plus 20 is what gives me 35. It's because these are interchangeable. It doesn't matter which one's 15 and which one's 20. Okay? The point is, if I now know those lengths, I can figure out the area, and I can say my area equals 1/2 base times height. And I can flip-flop them, it doesn't matter. So half of 20 is 10, and 10 times 15 is 150 square centimeters. Okay, so we had to set up a system using the word problem, so a little bit of an extension to a system. Okay, all right, go ahead and flip over. All right, we have the area of a circle can be found using area equals pi r squared. Given the equation, what is the length of the radius? So we kind of talked about this the other day. So if I want to figure out the radius, this whole thing right here represents my radius, because notice that it would be pi times r squared. So this represents my radius, that x plus 6. Okay, so right now I'm just thinking solve for x. If I divide both sides by pi, those pi's are going to cancel, leaving me with an 81 equals x plus 6 squared. Square root both sides. Remember that when you take the square root, you always get a plus or minus. And then I want to subtract 6. Okay, I'm going to write this out just so we can see it. So if I have a 9 minus 6, I could also get a negative 9 minus 6 because of that plus or minus. So 9 minus 6 is 3, and negative 9 minus 6 is negative 15. Okay, those are not my answers. Those are not even my radius. I need to go back in here and say that the x plus 6 was what was representing my radius. So if I substitute in this 3, that would mean that my radius is 3 plus 6. My radius is 9. If I substitute in a negative 15, that would mean my radius negative 15 plus 6 would mean that my radius is negative 9, which doesn't make sense. So in this case, it would be 9 units. Okay. Number 4, so we have a system. It says, and this actually I pulled off of the SAT. This is how they word it. They say, if xy is the solution to the system of equations above, what is the value of xy? So this means that when you find your coordinate, you're going to multiply those values together. Okay, notice that we have x, so if this is our x value, I'm going to substitute it into here. So I'm going to say 4 times y plus 1 over y equals 6. Okay, so I want to get rid of my denominator, which I can do by multiplying by y. I can also make this a fraction, which makes it easier to see that I'm cross-multiplying. So if I cross-multiply, 6 times y gives me 6y. And 1 times this, I'm just going to distribute here, gives me a 4y plus 4. I subtract, I get 2y equals 4. I divide, I get y equals 2. Okay, so this is my y value, which means I need my x value. So I'm thinking, what's x, but I know that y is 2. Okay, I can substitute into either of these equations. I'm going to substitute it into the first one, and I'm going to say x over 2 equals 6. So multiply both sides by 2, which means x is 12. So that would be my coordinate. The question wanted to know what xy was, so that means I would do 12 times 2, and xy is 24. Okay, so same idea as solving a system. The SAT just likes to take an extra step. So instead of leaving our answer like this, like we normally would as a coordinate, they just want you to find the product of the two. All right, let's look at number 5. Number 5, same idea. I took this one off of the SAT as well. It says the system of equations above has the solution xy. What is the value of x? So notice in this case, even though it's a system, they just want you to find x. They don't want you to find both. Oops. Okay, so I'm going to start by saying if this is y, I'm going to substitute it in here. So when I rewrite that equation, it's going to be 1/2 times 2x instead of y plus 2x equals 21 over x. And now I have an equation with all x's. So this is going to be 1/2 of 4x, or you could distribute, make it 1x and 1x. Half of 4x is a 2x, which equals 21 over x. Okay, I always want to get rid of that denominator, so I'm going to multiply by the denominator. So when I multiply by x over here, I get a 2x squared equals 21. I can see it's quadratic, but I also can just solve this by undoing these steps. So I can divide by 2. That way I don't have to factor because it's not going to be factorable. So I get x squared equals 21 over 2. Take the square root. Remember that when you take the square root, you get a plus or minus. And then these are not perfect squares, so I'm actually just going to leave my answer like that. So what is the value of x? I don't need to substitute back in. This is it. All right. All right, last one. The expression above is equivalent to a over, and this one I took from the SAT as well, so I kind of want to show you how they approach these problems and how they can be kind of confusing, but how you can use what you know to get past the confusing wording. Okay, it says the expression above is equivalent to a over x plus 2 squared. This is just an apostrophe, so we can ignore this. Where a is a positive constant and x is not equal to 2. What is the value of a? Okay, first of all, this x does not equal -2 is because if x was -2, this would give you a 0 as the denominator. You would have -2 plus 2 is 0 and 0 squared. So again, remember you cannot divide by 0. So they're saying x cannot be -2 for that reason. Okay, let's say that you were really confused as to what this problem was saying. Here's what I would suggest. I would say... let's go with this. I would say ignore this. Okay, so let's say that we didn't even see that. And let's say that we just focused on the actual problem and we just said, okay, what is this problem looking like? What is it asking us to do? If it's asking us to subtract, we must have a common denominator, right? So if this denominator is x plus 2 squared, that means it's x plus 2 times x plus 2. You'll notice this one has an x plus 2, so that means that the least common denominator is x plus 2 times x plus 2. So this one already has the denominator. This one I'd want to multiply by x plus 2 over x plus 2, and now they'll have a common denominator. Okay? So what that means is that first fraction, that numerator is going to stay the same, and it's going to be 2x plus 6. And then I'm going to subtract, okay, and notice that I'm going to pull this negative right here, and I'm going to distribute it here. So that's going to give me a -2x minus 4. So be very careful with that minus sign. All right? Positive 2x minus 2x is going to cancel, and 6 minus 4 is going to give me a 2. Well, there's nothing that I can do with the 2 to simplify it, so then that means I would say 2 over x plus 2 times x plus 2, which is the same as saying 2 over x plus 2 squared. So same thing, okay? Now if I go back to my problem, so if you think about it, I just subtracted, which is what my problem is actually asking for. And if I go back and reread this, it says the expression above is equivalent to a over x plus 2 squared. Well, that looks exactly like this, where a is a positive constant and x cannot be negative 2. What is the value of a? Well, a is just our numerator. So what is the value of a? Our numerator is 2. So this answer is 2. Okay, again, it looks like a complicated question on how they word it, but when you get stuck on that on the SAT or any type of question, ignore the wording and maybe just go back to the math problem and just say, what is it asking me to do? If it's asking me to subtract, how do I subtract? Okay? You are going to get the test review. Test is on Tuesday. Okay, you're going to have tonight to work on the test review, all day Friday, the weekend, and then Monday will be a shortened period. I would make it your goal to get as much done as possible tonight, tomorrow in class, and then I would try to finish it over the weekend or get very close to finishing it. That way you can come in with questions on Monday. Okay, it does look like it's going to be a lot of problems. However, remember that, you know, with each skill, you're going to want a couple of each. So you're going to want a couple of simplifying, a couple of multiplying or dividing or adding or subtracting. And then when you go to solving, you're going to want a couple of each, solving rational, solving radical, solving systems. And in general, they take a lot of space. So there's not very many problems on each page because they do take a lot of space. Okay? All right. I will be back tomorrow. Thank you.